Good afternoon, my dear kids. In today's class, in the chapter kinematics, we are going to discuss some calculus-based questions, or nothing but what you can call this as like a variable accelerated motion. If acceleration of a body varies, then how to calculate the all other parameters of the motion. So later part, again, when we go for the next week, the graphs, the same thing using graphically, we are going to explore here. So today, just like some variable accelerated motion, if acceleration varies with the time or position or with speed, how we can manage numericals. That's like some sort of introduction it is. The next week, we are going to explore everything again in depth through graphs. Now graphs will not be there, only some equations. Looking at that equations, how we can analyze the motion. That's what we are going to learn in today's topic here. Let me start the class. So let's directly begin with a situation. It'll be easy for you. The acceleration of particle varies with time as a equal to 3t plus 2 meter per second square, where t is in seconds. At t equals 0, the particle is at rest. Find the velocity of particle at t equal to 3 seconds. So there's a question given. Look at, I think that the first time where the acceleration is going to vary with the time. I'll magnify it. You can view it. So all these are, we are going to take help of the differentiation and integration. If you can recollect the integration and differentiation, those things we are going to apply it again. That was dy by dx, here it will be dv by dt. Instead of y and x, you get either vt or vx, that one. So nothing big, all these things. Okay, now a equal to 3t. So this one. So what is the approach for this? So here we know there's a given thing, a equal to 3t plus 2. Whenever acceleration varies with the time, so we are going to write it as dv by dt. If acceleration is a function of time, better to express acceleration as dv by dt. If acceleration is a function of position, then we are going to express it as v dv by ds. There's a formula. I think this much is what you have to learn, nothing new. Okay, yeah, Surohita, Vishal, fine. If acceleration is a function of time, express the acceleration as, replace acceleration as dv by dt. If acceleration is a function of position, then express acceleration as v dv by ds. So look at the acceleration. It is, in fact, it's a function of time. So based on this, so this can be written as dv by dt. At t equals 0. Now simplify it. 3t dt to dt. Okay, this will be the limit. Next step will go for the limit. dv is equal to 3t dt to dt. Now, okay, let's come for the limit. At t equal to 0, at t equal to 0, the particle is at rest. And at any time t, let v be the velocity. Okay, Veena, yeah, agreed with the answer. This will be further. Integral of dv will be v equal to 3. This will be t dt will become t square by 2, 0 to t. This is t. Integral of dt will be t, 0 to t. So v, this will be upper limit minus lower limit. Upper limit minus lower limit equal to, this will be 3 by 2. Now look at here. Upper limit is t square, lower limit 0 square plus 2, t minus 0. V equal to 3t square by 2 plus 2t. Okay, this is the equation. Now you have to find out the velocity of particle at t equal 3 seconds. You could have put that limit here only. That's the first problem I just wanted. Look at the velocity now. It is in fact varying with the time in this one. So now velocity of particle at 3 seconds. So 3 square plus 2 into 3. 9 3 27 by 2 plus 6. 13.5, so 19.5 meter per second. What is the core idea? The method is this one. You have to make observation. What acceleration is a function of time or a function of position? Based on that, the replacement has to be done. Further, can we calculate also position of a particle as a function of time? Let's assume that at t equals 0, the particle is at rest and is at origin. Well, I'll just let me modify and is at origin. So that we'll get exact picture. Is at origin. So therefore, now this equation further, it will be v equal to 3t square by 2 plus 2t. This will become ds by dt. ds is equal to, this will be t square dt plus 2t dt. So the limits will be 0 to s, 0 to t, 0 to t. The position of particle, this will be 3 by 2, t cube by 3 plus 2, t square by 2. S is equal to t cube by 2 plus t square. It's a definite integral. We have substituted directly. I wrote this one. So this will be the expression for position of a particle. Now, what is S? S means position. Position of particle at time t. So if you know acceleration as a function of time, can you calculate the velocity or speed of a particle as a function of time? Yes, it is. Can you predict the position where it will be? Yes, you can predict here. It's a purely mass based. Some small idea will be there. That idea is what you have to grasp it here. Okay, scribble it first. Let me go to the next question.
Sir, can you scroll up a little bit, sir? Done, sir.
The acceleration of particle moving along x-axis is given by a equal to 3x plus 2, where x is the position of particle at any time t. At t equal to the particle is at x equal to 2 meter. Find the velocity of particle at as a function of x. Okay, what is the method? Okay, there's a background. What is the background? You need a background like this. So if you know acceleration, we know it is acceleration equal to dv by dt. This I'll just dx dx here. So this can be written as dv by dx, it is dx by dt will become v. So this will be in very popularly, we write it as acceleration equal to v dv by dx. Yeah, let me wait for answer. Surohita, I have to wait for answer. Let me solve it. Okay, equal to v dv by dx is what we'll get it. So here like this, you can bring acceleration as a function of position. Okay, let me write here. So the given equation is a equal to 3x plus 2. So this will become v dv by dx equal to 3x plus 2. This is x here, not into mark. So further, v dv equal to 3x dx plus 2 dx. So this will become v dv equal to the particle at x. Find the velocity of particle as a function of x is asking. Okay, now the limits little bit we have to be careful. What can be the limit now? At x equal to at t equal to 0, the particle is at x equal to 2 meter. At t equal to 0 is telling. But what we needed here, the limits are v and this one, no? I think read once again the sentence clearly. At t equals 0, the velocity at any time t. At t equals 0, the particle is at x equal to 2 meter. Only that much of information is what we have. And let's assume that initial velocity is how much. Okay, this we don't know. So at x equal to t equal, the particle is at x equal to 2 meter. I'll put it this. Initial velocity, I don't know. Intentionally, I gave this one. We are not very sure that it is at rest or in motion. Okay, now as a function of x, let it be. Information was not available. Just leave it. At t equals, sir, how can you can say initial velocity? Because at t equals 0, the particle is at t equals 0, the particle is at rest at x equal 2 meter means you are going to put u as 0. Able to understand that the limits are very important. The limits are defined based on the condition. There's no further information given whether the particle is at rest or in motion at t equals 0. So therefore, let me assume just value of u. We can't do anything here. If I add up at x equal 2 meter and is at rest, then you have to put 0. Okay, all of you? These are some things which you might find difficult in an exam. That's why intentionally I brought the sentence of this kind. So this will be simplification of this will be v square by 2 uv equal to 3 x, that one. So this will become v 1 by 2 upper limit minus lower limit. Here. In place of v upper limit, then lower limit u square. Okay, then this will be 3 by 2 x square minus 2 square. 2 x minus 2. Okay, this will be 3 by 2. This will be x square minus 4 plus 2 x minus 2. V square, this u square you can. This 2 we will take common. So this will become v square minus u square equal to 3x square minus 4 plus 4 x minus 2. U square 3x square minus 12 4x minus 8. U square 3x square plus 4x minus 12 minus 8 minus 20. I think how you don't get any value here, no? Find the velocity of the particle as a function of x is asking. This will be, if initial velocity given 0, put u 0. If at t equals 0, the particle is at origin and at rest, then the what will be the limit? Limit will be x equals 0, 0, 0. This will be. So these values, lower limits, depends upon the conditions available here. If initial velocity is 0, then put 0. Initially, the particle is at rest at x equal 2 meter means, then you are going to put that as 0 here. The limits you have to define based on the conditions given. That's what in the entire discussion here. Write down first. We'll go for the next question. See, one thing.
The answer.
That's all. Why you'll get numerical value. I'll share it. I'll write it down. This will be your answer. Okay, this whenever the acceleration function of position, okay, you have to write in this way, equal to v dv by dx. Okay, write it down first. I will take the next question. I think now everyone got certain idea, acceleration function of time. Don't get scared. dv by dt, acceleration function of position, v dv by dx. Then what all unknown things asked? Okay, based on that, you have to integrate things. How to substitute limits? You have to read the question and get the conditions properly. The initial thing all. I brought all thing in a very systematic order. This are very good for learning things. And you have to understand here rather than remembering. Your entire effort should be to understand things here. Read the content, read the data given. The acceleration of particle moving along a straight line varies with velocity as a equal to 3v plus 2 meter. The velocity of particle at t equals 0 is 3 meter. Find the velocity of particle at t equal 2 seconds. Acceleration, first problem, acceleration was a function of time. Second problem, acceleration was a function of position. Third problem, acceleration was a function of velocity or speed. Okay, no? Different things. Now this, we know that there's a given 3v plus 2. Acceleration, dv by dt. Sir, I will write this as v dv by ds. Okay, you can write it, but you see then what you get here now. Velocity of a particle as a function of position, you can express it. Now I want the information like time is given, so therefore I'm writing it. We will solve for this also. Provided you should be very good in integration, that's why I'm trying to avoid. Later at the end of the problem, we'll see such. Okay, now this will become dv equal to 3v plus 2 equal to dt. Then this will become d3. Let me take common from here. It'll be easy for you to integrate. So this will become dv by v plus 2 by 3 equal to 3 dt. What should be the limit? Let's look at the things given for us, then we'll decide the limit. The velocity of particle at t equal to 0 is 3 meters per second. So the limit at t equal to 0, the velocity is 3. Find the velocity of particle at t equal to 2 seconds. So at any time t, first we'll write expression because this will be useful for us. Then in the equation you can put it, or in the exam what you should do, you cannot simplify. Directly what you should do here, you have to put here t equal to 2, solve it. You get expression for, you get the value for v here. The simplification of this will be dx by x plus a, if you can remember formula, log of x plus a, it will be log of v plus 2 by 3, 3 to v is equal to 3t. Integral of dx by x plus a should be equal to log of x plus a. This is the formula. You have to remember. This is what we used here in this question. Take my help. That's what this equation is telling. Don't get scared. Everything we have already, we had a nice platform we made ourselves before coming to this particular topic here. Integration, differentiation, we worked out. Those things we are applying it here now. Now, let me substitute upper limit v plus 2 by 3 minus log of 3 plus 2 by 3 equal to 3t. Log a by log a minus log b can be written as, okay, one more step, I'll write it. Log of, this will be v plus 2 by 3 minus log of 3 3 9, 11 by 3 equal to 3t. Log of v plus 2 by 3 by 11 by 3 equal to 3t. So this will become log of 3v plus 2 by 11 is equal to 3t. Now what to do now? Okay, we know we can convert this into exponential. Log sending on the other side will become exponential. This will become e to power of 3t. So this will become 3v plus 2 equal to 11 e to power of 3t. V is equal to 3v equal to 11 e to power of 3 to 3. Okay, this will be our expression for the velocity. I think everyone knows how to plot graph. Interested you plot this graph? But in exam not needed. Exam now what is asking? Find the velocity of particle at t equal 2 seconds. So what we should do? So the speed of particle at t equal 2 seconds will be v2 is equal to 11 by 3 e to power of 6 minus 2 by 3. You know value of e, substitute there, solve it, you'll get certain value.
There, why we are taking T3 as common?
3t, where I took common?
No, sir. 3 dv by 3 into v plus 2 by 3.
Because the quotient of integration, the quotient of this 2 should be equal to 1, no?
Okay,
In integration,
sir.
we have seen. Huh?
Sir, one doubt I'm having, sir.
Sir,
You got ln v plus 2 by 3 is equal to 3t, no, sir? Then you substituted limit, sir.
Yeah.
Okay, sir. Okay, sir.
One 147857. Oh, value. Okay, okay. Thank you. Thank you. Thank you. One 147857. Thank you, Abhiram.
Sir, there we can take log to the base 10 also, sir. or only log to the base E?
Log to the base you take it, ma, because the other side E will be there, no? Here again locked in. How do you know the values? Huh?
Okay, sir.
Sir, here, how did you know that we need to put V and T in the limits, sir?
That was the method, no? That's what you did in integration then. The integration, why we studied integration for 2 days for this purpose only. Because see, what is a variable here? I am asking velocity as a function of time. So therefore, do I know at t equals 0 what is velocity? 3 meter. Then I want velocity of the particle at 2 seconds. So therefore, what I should do? Limit now. Shall I put jalebi there, chocolate there, ice cream there, limits, or shall I put t and v? T and v only. At t equals 0, what is the initial velocity? At any time t, what is the final velocity? Okay, ma? Huh? So this comes by practice, huh? So don't think there's some concept is there. No, you have to read this data. Find the velocity of particle at 2 seconds. At 0 seconds, 3 meter. That's what the limit. No, here. What is this t here? What is the t? You tell me. Time, no. What is v? V is the velocity. At t equals 0, 3 meter. At time t, the velocity bv.
Okay, sir.
There's no other way. You have to fight back. You have to fight back. Why the limits are there? You have to read that question. First, you have to understand the question there. What was the question asked first? If you don't understand, then you'll never understand why the limits are taken. So please, all of you, find the velocity. So what is the information? Yeah, he's asking you to calculate velocity t equal 2 seconds. So why don't you think on this first? Actually, this topic I was not supposed to teach because already we have done integration differentiation. Finish sure. The first part, like if I'm very good teacher, if the teacher is very good, then you should just say like, say all some 30 problems which are calculus based are there, around 50 are there. For that, you need this approach. It's over. Because already you know integration, differentiation, you know acceleration, you know velocity, you know time, you know position. The teacher help is only needed till here. If acceleration as a function of time is there, then write dv by dt as a function of position, write in this way and solve the problem. It's over. This one. I'm telling this one, the topic is over. Anybody interested, you can leave the classroom now only. Really, no, sir, I'll manage my own. Okay, you can carry on. I don't have any objection. Okay, no, so that should be our like a skills, like integration differentiation you have studied. Instead of y index, you are having v and t or v index. Mathematics, I told you, mathematics you should learn how to use, not just to solve the questions. But the biggest problem is we do learn just like some equation, they're gone. Now read the question. A particle moves along a straight line in such a way that its acceleration is increasing at a rate of 2 meters per second cube. Its initial acceleration and velocity were 0. The distance covered by it in t equal to 3 seconds. Find the distance covered by it in t equal to 3 seconds. Look at the sentence. Intentionally, this is brought here. It's acceleration. Bring your English, all of your English medium. You should put effort to in understanding interpretation of words, sentences. What is the meaning of it? Sentence by sentence, you have to break up. You have to think, analyze. All of a sudden, nothing will come here. See, English is not our mother tongue. It's a very sad state that we are learning everything in English. If this were in your mother tongue, no, you would have understood all things very easily. So, but no alternative. For us, there's no alternative. Anyway, you have studied for 10 years English language. So to some extent, you should know how to manage things. Veena, okay, fine. Yeah, agreed. dA by dt is what? 2 here. Anybody can write this. I think problem solved. Vishal check once. Vishal check once. Abhiram, okay, agreed. Vishal check once answer. dA by dt is equal to 2. This is, I think, the interpret the yellow color sentence what I highlighted. Its acceleration is increasing at a rate, means dA by dt. Velocity increases at a rate, dV by dt. The rate of change of displacement means dx by dt. Acceleration increasing at a rate of 2 meter per second cube, means it is like dA by dt it is. So how do I come to know? That is what your language should come into picture, and you know a little bit of kinematics now, and you are from English medium. So bring all this. So that's why physics, why students struggle a lot. Shall I tell you one thing? The basic problem is like the language and application of maths. If these two are there is nothing called in physics. Language means, again, don't buy grammar book, will not help you. The minimum simple words you should know how to interpret for the given situation.
Sir, the units of acceleration are meters per second square.
Look at my rate. Why don't you are English medium student, dA by dt, rate.
Okay, sir.
Vishal, okay now. dA equal to 2 dt. That's all directly. dA is equal to 2 dt. So dA equal to. Please don't get scared because I'm scolding some of you very, very harshly. Let it be this one, because this what, like, I should not make you happy. I should really tell you what is the state of you, what you're thinking, what is the wrong. Then only things will set right. No, if I just make you happy, then the meaningless all this one. Huh? So don't get scared. Okay, let the teacher get scolding. Let them insult you, because you are here to learn the things. Let it be by any means. Okay, ma, Surohita, agreed. Okay, somehow like a dA, I got it. So here I'm going to this will be the limit here like this. So at t equal to 0. So initial acceleration and velocity were 0. Look at the limit. Initial acceleration and velocity were 0. So therefore at t equal to 0, what is acceleration will be 0. So a is equal to 2t. Then find the distance covered in t. So we have acceleration. Kankshit SX agreed with your answer. Kankshit agreed with your answer. Now
Sir,
further,
which one said that? I have sent it twice.
yeah, that one only. Yeah. Huh? So acceleration equal to further dV by dt. Then again, what is the limit? At t equals 0, the particle was at rest. At any time t, let it be here. So then solving this, v is equal to 2t square by 2. Find the distance covered is asking. So what shall I do now? Further v as ds by dt. Again, the limit. Find the distance covered by t seconds. So this will be s, this will be t. So this will be s equal to t cube by 3. At t equals 0, if it were at origin, so not mentioned. Okay, we'll take it that one to be. Its initial acceleration velocity was zero, and at t equals 0, the particle was at origin. Then only we can write this limit as 0. Okay, agreed that one? I'll add up this. At t equals 0, the particle is at origin. If it is not at origin, that you have to substitute the limit here. So this will become, now put 3. Nine meter. Veena, I'm not understanding something you are saying. You should not use V equal to U plus AT formula. At least, why? Because the acceleration is varying. This is applicable only when for uniform accelerated motion. Anything? Both are same, no? This is our answer. Read the question. A particle is moving along a straight line with an acceleration given by initial velocity at t equals 0 is 5 meters per second. Find the distance traveled and displacement of particle in 12 seconds. I am really bringing the problem where you're going to get a good trouble. He's asking find the distance traveled and displacement of particle in 12 seconds. At t equals 0, let it be at origin. We'll write initially initial velocity at t equals 0, 5 meters per second, and is at origin. We'll write initially and is at origin. We'll write it at t equals 0. We will add up this condition. (228). What is that 228, Vishal? Distance or displacement?
Displacement.
Displacement. Okay, fine, I agreed. Yeah. Minus 228 or plus 228?
Minus.
Minus 228. Okay. Okay, agreed. Yeah. Veena, check your answer. Surohita, okay, agreed. Displacement or distance, you are supposed to say?
Displacement, sir.
Displacement. Okay, yeah. Distance covered. You have to find out.
Sir, we can draw AT graph and also we can do, sir.
Your wish, your wish, I won't answer any method. If you are very good in graphs, plot the graph, work out. Let me proceed like this. Acceleration is equal to 4 minus 2t. This will become further dv by dt equal to 4 minus 2t. Srinitya, okay, I agreed with your answer. Negative sign should be there, check once. So dv by dt, acceleration is dv by dt, 4 minus 2t, will write it. So this will become dv is equal to 4t. Displacement minus 228 meter, agreed everyone. Huh? Okay, no need to put in chat box. Abhishriari, Jaya, Shirisha, okay, agreed with your answer. Others who all got answer, no need to put in chat box. Okay, fine. Now, at t equals 0, the limits will be t equal to 0. Initial velocity at t equals 0 is 5 meter. There's a 5 meter. At any time t, let it be v. Distance also 228. Let's see, Vishal. Okay, I'm going to integrate this. This will become v minus 5, 4t minus t square. Directly I'm writing, or one more step. 2t square by 2, 0 to t. One step. The next step will be v minus 5 is equal to 4t. 2 get cancelled, so t square. So v equal to minus t square plus 4t plus 5. Okay, this expression for find the distance traveled and displacement they are asking. Okay, we got the velocity now. This is there. So now to get the displacement, so directly dx by dt, I'll write it. Next step, I'll add the limits. So this will be so this will be the limits. Now look at the condition at t equals 0, it was at origin. It was at origin. At t equal to 0, it was at origin. At any point, at any time t, let s be the position of particle. So then solving this, s is equal to minus t cube by 3 plus 4t square by 2 plus 5t. So there's the expression for the position of particle at t equal to 5 seconds. The question what is, find the displacement of particle in 12 seconds. So we'll write it minus, this will be 12 whole cube by 3. So this will become 2, 12 square plus 5 into 12. So this will become how much it is. Almost everyone gave answer. 228 meters. There's a displacement. There's no problem here till here. Now distance travel. What to do now? Okay, I have a method. I have a method. Look at the equation. I want everyone to look at this equation here. This is the something it's going to help us here. With velocity means how the motion of this body occurs. The velocity is one which will tell us the direction of motion. Am I right? Not acceleration. In what direction? Velocity positive, moving along positive x-axis. Velocity negative, the body is moving along negative axis. The velocity is going to tell us in what direction it is moving. So is there for any instance of time, will it change its direction? Means certain values v is positive, certain values of time between 0 to 12 seconds. Put t equal to 0. What is the velocity of particle 5? Put t equal to 1, t equal to 2, t equal to 3, put t equal to 12. For certain values from 0 to 12, the velocity is going to take the positive value, and for certain values of time, it is taking negative value. What do you mean by positive and negative values of velocity? It's going to change the direction of motion. If v positive, it was moving along positive x-axis. V negative, it is moving along negative x-axis. Then definitely, you go back to the kinematics. If an object just moves like distance covered equal to displacement, okay, I think there's no problem. If an object moves and changes direction, then in this case, distance covered will not be equal to magnitude of displacement. Distance covered, no need to repeat again, once again. Happily listen for teacher, huh? Or else I'll be aside, you only teach it. So what is D? D is a distance covered. It will be greater. So I'm just wanted to tell you that they're not equal. So I think now, is this motion of this kind? If it were this kind, there's no problem. If we were of this kind, definitely we have to think about the alternative. What mass you can use to find out. How to check the motion is of this for 0 to 12 seconds. If the velocity doesn't, if it takes only one sign, then it doesn't change its direction of motion. For between 0 to 12 seconds, if the direction of velocity, if we will have both positive negative values, means it is changing direction of motion. In that case, the distance covered, the displacement and distance covered will not be equal. That is the basic idea. Now, how to check? Okay, you have the simplest method. Put t equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you'll get the velocity. S definitely is changing. Okay, after changing that also, after getting the tabular column, can we do it? Again, still very difficult. So therefore, we need some method. We need a technique. As we have the integral calculus to help us. The calculus is going to help us here. The whole idea of calculus is application. The calculus is nothing but based on application. You must know how to apply calculus. That's all. Now, this I'll take it out. Definitely, I think I'm very sure that for certain values, V is positive, for certain values, V is negative. Then how do I come to know, sir? Like how you are telling that one? So we'll do one thing. Like if an object is moving like this, for it to change the direction, that too in accelerated motion, what is the necessity condition? So first, what will happen? It should undergo its speed should decrease, become 0. Then only it can change the direction of motion. No? I think you are going on a bike. I'll ask you to return back. What you should do first? So you'll be moving with certain 10 meters per second. To return back, what happened? Your 10 meters per second should decrease, should become somewhere 0. Then you'll start moving towards left. No. So for an object to change the direction of motion, what is the necessity condition? Somewhere velocity should be 0 during the motion. And once you get that time, for t less than that, check it, we will have positive values. For t greater than that particular value, t naught will put it, the velocity will be negative value. So it changes direction of motion. That will help us to calculate the distance covered. So what is the basic necessity condition? For an object to change in direction, somewhere in between the motion, the velocity should be 0. Yeah, that's all. All the quadratic equations, you have so many things, you are going to bring that into the picture. So now I am going to write let v equal to 0. Then the quadratic equation. See, many were objecting me, sir, why you are teaching basic mathematics? What all the maths you learned, if you know how to apply, very good. Okay, this one. So we'll solve this. There's a quadratic equation. T is equal to -4 plus or minus 4 square minus 2 into 1 into 5 by 2. 16 minus 10 by 2. Root 6 by 2.
Sir, b square minus 4ac.
Or 4, no? Okay, I think I forgot. So
Okay, sir.
16. Okay, this 4ac, no, minus 1. I'll come. Okay, this will be, I think 20 will come plus 20, 36. So this will become 6. So I think time should not be negative. So what is the instant of time at which it will v equal to 0? I think 1 second. Shall I put 6 minus 4 by 2 will be 1 second. Now put t equal to 2 seconds, the velocity will have one value. Put t equal to less than 1 second, it will have the velocity will take the opposite sign. So therefore, at t equal to 1 second, what happen? It is going to change the direction of motion. I think that is enough for us to break up the integral. Now, what is asking from 12 to now? One more trouble. What is one more trouble? Sir, for 0 to 1 second, in what direction it is moving? Do we know that? We need not to bother. After 1 to 12 seconds, how in what direction it is moving? Let's not bother. But altogether, the object, it is. Now, this will be very fundamental. Everyone try to understand. So the velocity, what happened, will have certain, you just put like, so the equation for this. So definitely, can we just put like a 1 by 2 seconds? You can have certain idea in what direction it is moving. Anybody gives me value, it will be useful for me. Somewhere at t equal to greater, let me put it. So this may, let me take the 2 seconds, that is enough. Time should not be negative.
Sir, both will get positive only, sir, at 0.5 and 2.
Now 0.5, what you're getting value?
Sir, the calculation you did wrong, sir. It should be
Yes,
minus
sir.
2, sir, in the
Okay.
denominator. T equal to
Denominator.
Yes, sir.
Yeah.
in
Okay,
minus
yeah,
2.
minus 2. Then. Okay, then I have to change everything.
Minus 4,
Somebody
minus
give
6.
me.
Sir, T is equal to -1 or 5 seconds, sir.
5, sir.
Minus 1 or 5, sir. At t is equal to 5, v will be 0, sir.
5 seconds and minus 1 second. Negative sign should not be taken. Okay. Okay, thanks for helping me. Okay, this is not possible, no, minus 1 second. Time should not be negative. So therefore at t equal to 5 seconds, in fact, it's going to change the direction. Now we'll break up this, our entire motion into two parts. For t less than 5 seconds to 0, let's see. Just as some rough idea, put t equal to 1 second, let it be.
Positive, sir.
You'll get the direction. Positive one. Okay, this will
Yes,
be,
sir.
v will be positive. This will be negative.
Negative.
No. So for 0 to 5 seconds, it will move along positive x-axis. After 5 seconds, it will change direction of motion. Getting the idea? Now this is, so now what we are going to do is, with this is enough for us. You need not to bother all this one, just only get the time where it is only positive values you have to consider. Now I'm going to bring the integration into the picture. Distance covered is needed.
Sir, in the two, in one equation, 5 should not be included.
It's a limits here. Just I wanted to show you that very next moment, after just greater than 5 seconds, it is going to negative that one. It will change the direction. But the limits we put like this only, the condition.
Sir, for 5 seconds, V
Okay,
is
then.
positive or negative, sir?
Okay, I'll do one thing.
0.
Okay, now I agreed, huh? Because
Yes.
even just for another infinitesimal time, it will change direction. No, therefore in the mathematics, it's a practice of putting less than or equal. So you didn't like it. Okay, I'll change the condition. No. Okay, after this, what to do now? The distance count. So I'm just going to take help of this equation. ds is equal to integral of v dt. I'm going to break it up. Everything we are going to do it here. So let's have that equation v equal to I'll bring extra page y to hope everyone is able to visualize. So now this will be this. I'm going to write it as v equal to ds. ds is equal to v dt. Sir, already is there. Then why you are making this one? Now you can see the condition. This I should integrate. So I'll break it up 0 to 5 v dt plus 5 to 12. No repetition, please. Happily listen for teacher. No, why you want to repeat? Huh? So why you are breaking up? I say actually we need not to bother this. The mods will help us because the distance covered. Actually, the motion, how it takes place, the motion of the object. In fact, I'm giving rough. I'm in fact, the motion takes place like this. At t equal to 0, it will start here. This is at t equal to 5 seconds. This is t equal to 12 seconds. Somebody gave that 228 meter. The 228 meter is something this one. Now, during 5 seconds, it was moving along positive axis. After 5 seconds, it was moving along negative x-axis. How do I come to know? This is also a big trouble. So therefore, what we do is just put v equal to 0. You'll get a time. That one. Break up that limit now 0 to 5, 5 to 12. Now among them, which one is positive, which one is negative? We need not to bother. Put mod for both. Why mod for both? Because which one is positive, negative? Again, we have to verify. We have to substitute t equal to 1. It's a waste of time on. Because anyway, we want a distance count. We have to add up this and this. So therefore, the one which is negative, I don't know. That's why I'll put mod for both. The one which is negative will be nullified. Getting the idea? Trick here?
Yes.
The mathematics here too. So why the mod is brought is like we need not to bother about like a which one is positive, which one is negative, for which interval of time v is positive or negative. We need not to bother this. Just put t equal to v equal to 0. You'll get a time. Then 0 to 5 seconds. Is it moving along positive axis? Let's not bother. Put mod. Is it moving along negative axis? We don't know. Put mod. The one which is negative will be nullified because we have to add up this plus this. No, this is quite easy. Now we have to integrate and we have to substitute the limit. Total distance covered. This will be S is equal to, now I'll proceed here. I'll make it, okay, now you can see things clearly. Now we'll get into the calculation part. S is equal to, what is the value of V? Minus t square plus 4t plus 5 dt 0 to 5. See, calculus is such a versatile tool. No, it's a very, very powerful. I'm telling this one. You must know how to apply this. That's what your entire engineering role revolves around.
5 to 12, sir.
5 to 12. I didn't. Okay. This will solve it. S is equal to is a very lengthy. It's going to be minus t square dt 4t dt plus 5 dt mod of it. The limits 0 to 5, 0 to 5, 0 to 5, 5 to 12. Please just calculate now. If you tell me that, I'm going to just add up those values there. Anybody? The first mode, the magnitude of that? First one, do simplification, substitute upper and lower limits. Preksha, check your answer. Distance covered cannot be equal to displacement.
Sir, will get less than, sir, if you do like this.
How come when you add up both?
Sir,
Okay,
one term will be negative, no, sir. Remaining both positive, sir. Minus 125 by 3.
How much minus?
125 by 3 plus.
Okay, I'll do it.
Minus 125 by 3 plus 75 I'm getting, sir.
The other mode is 75. Huh? No, check once all.
No, sir. First mod only, sir. Minus 125 by 3 plus 75.
Oh, total. Give me the value. I'll just dump the value. Positive on with sign you give it. I'll write it down here. Huh?
32.6. First mod.
32.6. Huh? Asnika 261.33. It should be greater than 228. $200 by 3. Okay. $294. Some different answers. Oh. Total value. No, I want this mod value. You tell me so that it'll be easy for me. This value I want it. The left mod. First mod is 100 by 3. Preksha. Okay, 100 by 3. Negative.
Positive.
Positive. Second one. $100 by 3 plus 228. You add up. That'll be the second one. Because this what 100 by 3, no? 100 by 3 plus 228. That should be the value of this one. I'm using logic.
261.3, sir. If we add 100 by 3 plus 228.
No, you can't. Okay, this one, this value.
No, sir. After adding 100 by 3 plus 228, I'm getting 261.3.
I'm asking you to work out. No, don't use logic. I'm asking you to solve this and tell. No. 261.
No, sir. 100 by 3 plus 228 is 261.3.
That one only. Yeah, I wrote it. Okay,
Yeah,
the
that-
second. Why calculations, some maths I'm giving you, nobody is doing properly.
Sir, whole answer is 261.3, sir.
Then what is the mod value? This one
228.
28, sir.
mod value. Huh?
Yes, sir.
Yes, sir.
Then this should be 200 by 3. No, then this should be left mod. Second value 261 point.
261.34 seconds.
228 plus 33.33.
Okay, 261.3.
Yes, sir.
Yeah.
That's the final value.
This is the final answer. Huh?
Yes, sir.
Okay. Now, which one negative? Negative. The one which is negative.
Second one.
Second one negative. No. Yeah. Okay. The reason why we took mod, because the distance covered is needed. (228) is a displacement minus. I think it's not tallying. No, the way. Maybe diagram I didn't draw properly. Huh? Second value is minus 784 by 3. I don't know. Different students are giving different values here.
Second one only 261 will get, sir.
Second one, how much?
261.
Yeah. I'm going to that room. Anyone coming? I will open fan there. Anyone coming?
Rishivardhan, you can't unmute and talk. Please. Huh? Try to cooperate. There's a minimum thing. Can't you do that? Second one is second module, mod value, some, I don't know, different students, different answer. Whom to know? Calculation, please do, all of you. Please do calculation. Please do calculation. Leave it all. Calculate this, tell me the value. Don't bother anything.
Sir, second value will get 784 divided by 3. Sir.
First value 100 by 3
Yes.
only, sir.
Okay, check it now. It will
Total
be
294 will get.
total 294. Around it will be.
Correct only answer.
That's what everyone is giving different answer. Then whose answer I should trust?
294.66, sir, if we go up by this method.
Yeah. First of all, the mod values, nobody is telling any answer. I don't know. Simple
Correct only,
calculations
sir,
are there.
this one.
They're the correct only. Yeah, fine. Huh? Okay, now you see this. I think it cannot be 228. This cannot be 228. I'm very sure. Because 228 is from here, means it should be measured from here. No. So it should be greater than 228, this value. Okay. So now this will be our final answer. So like this, the distance covered. So whenever they ask you distance covered, I think you have to be extra alert.
Sir, using VTK also we can do, no, sir?
How you can do? Okay, again you have to work out the integration only, no, there.
Yes, sir.
Okay, just look at the calculation. I'll go for the next part of the problem.
So 784 by 3 is 261.3, sir.
Oh, that one. Okay.
That was the previous final value.
261.3. Okay, then fine. Huh? Because it should be more than 228, no?
Yes, sir. It's
Yeah.
228 plus 100 by 3.
Yeah, that one. I think this is correct, huh? This way. Okay, if you have this little bit some motion, okay, there's the first problem. Like this now, if you have if you find this difficulty, you know displacement, you know this. This is the additional distance will cover, add up this two, that's what this mod 1 will come. In fact, this will be negative. I gave this supportive diagram also. Please take help of such things. Now, can we calculate average speed for 0 to 12 seconds? Yes. Can we calculate the average velocity? Yes, we have everything in fact. No. So what is the average speed? How you define? Average speed is equal to distance covered by time taken. 294.66 by 12. What about average velocity? Displacement by time taken, which is 220 minus 228. What is the value? 228 by 12. This is I cap, I'll write it. Speed should not have average speed. This is the, I think you try to see this one. This is the average speed. This is the average velocity. So finally, if you know something acceleration as a function of time, can you calculate the average speed, average velocity is also S. Distance curve displacement S. I think we have started. I think I can't show more than, okay, our equation is A equal to 4 minus 2t. From that, we can find out so many things. Again, similarly, to trouble you, the question, the velocity of particle moving along a straight away, I'm giving velocity, then it's asking the.
Sir, what was the answer for the previous question? Final answer?
Final answer, that one we have concluded, no? 294.
294, sir. Okay,
Yeah.
sir.
Okay, this additional thing like this, you can get all other parameters. No? There's a distance covered, I'll write it. Okay, now similarly, speed of particle. Okay, we'll do this one. It's same similar problem. Find the distance covered, displacement, average speed, and average velocity for t equal to 0 to 2 seconds. The methodology is same. The methodology is same. So the first you start with this equation. So what is the method here like? Will it changes direction of motion to check? We have to check that one. So first I'll put let v equal to 0. Then the equation will be t square minus t equals 0, or t equal to plus or minus 1 second. Time should not be negative. So therefore I'm going to take positive value only. Okay, agreed this? Everyone knows this one now? No. After this, at t equal to 1 second, it's going to change the direction of motion. Then for t less than 1 second, how it is moving. For t greater than 1 second, let's not bother. Let's not bother. Directly, it's asking the distance covered. First average velocity displacement will calculate. So as we know, v equal to t square minus t.
Sir, T is 0 and 1, sir, not plus or minus.
At t equals 0, what is the condition there?
Yes, sir. But I'm
Okay,
saying that
okay, this one. Okay, sorry. Here I'll make it 0 or 1. Now, when it will change the direction of motion, at t equals 0, substitute the body is at rest only. The velocity will be 0. At t equal to 1 second, again v is 0. But is asking 0 to 2 seconds. So I should, now what shall I do? From 0 to 2 seconds, shall I go for 1 or 0? I think one only. Because at t equals 0, the velocity of particle is 0. At t equal to 1 second, the velocity of particle is this one. So we are describing the motion from t greater than 0. And from t greater than 0, the motion begins here. So 1 second is what? We are going to break the interval. So this will be ds is equal
Sir,
to.
at t equal to 1 second also velocity is 0 no.
Okay, let it be now. That's good, no, in fact.
Then sir, why we are not taking t equal to 0?
Our motion is from 0 to 2 seconds means as you start counting time, what happens? The t will become greater than 0, no? Use some common sense here. Just bringing blind mathematics here. What is the motion? It's a motion occurs, no? The moment you start counting time, t will become greater than 0. Now the limit will be at t equal to
25. 0
0 to 2. Okay, directly we are calculating the displacement here. This will become
Sir, is it 2 seconds or 25?
2 seconds.
Okay, sir.
S is equal to, this will become t cube by 3, 0 to 2 minus this will be t square by 2, 0 to 2. So this will become 8 by 3. This will become 2. 2 by 3 meter. This is what displacement I'll call it. Then distance covered. So for the distance covered, what we are going to do is like a ds equal to v dt. How to break up that?
Lower limit you have taken 0.
Huh?
Lower limit 1 we can take.
I am asking displacement, no, for 0 to 2 seconds. Then what shall I do? Okay.
Yes.
Mathematics, most of you are just blindly thinking mathematics here. Try to understand the motion first here. And now it will change the direction of motion. So 0 to, so therefore the limit will be 1, 1 to 2. Then which one is positive, which one is negative, we don't know. We'll put in this way. What we'll calculate now will be distance covered. So here distance covered, if you find difficult, D will write it. Huh? Instead of S, both are same symbol, D will write it, distance covered. So this limit now will substitute here. This will become t square minus t dt 0 to 1 mod of it. Okay, this will become t cube. One more step. Okay, t square dt 0 to 1. T cube by 3 limit 0 to 1 minus t square by 2 limit 0 to 1. This will be t cube by 3 limit 1 to 2. So this will become mod of 1 by 3. This will be 1 by 2. This will be 1 by 3 outside. 2 cube minus 1 cube. Two square minus 1 square. Altogether is a mod. This will be minus 1 by 6. 8 minus 1, 7 by 3. 4 minus, so this will be 2. So minus 1 by 6 plus 3 2 just 6 6 1 by 3. Are you getting now why we have to take mod? Please, some of you are asking, sir, why you're taking mod? Why for mod, sir? Mod should be for anyone. Tell me, like, which one is positive, negative? What else shall I do here now? It will take half an hour for me to again verify which one is positive, negative, all, because I should go for tabular column. 0 to 2 seconds, no? T equal to 1 second, it become V equal to 0. Then 0.1 or 0.2, 0.4, 0.5. 0 to 1 seconds, I should break interval. Again, 1 to 2 seconds. There I have to check it. Better put mod, no, because we want distance covered. Please do understand the mathematics here. The use of math is something very important. Distance covered. Anybody value how much it is?
Sir, the 7 by
1 by
3
2.
minus 3 by 2, sir.
Half.
0.5.
7 by 3 minus 3 by 2, no, sir.
7 by 3
1,
minus 3 by 2,
okay,
sir.
1 by 3. Which one here? This one, huh?
Sir, in the last third step, sir.
Okay, 3 by 2. 3
square
by 2
minus
it will
1
come.
square.
3 by 2 it will come. Okay, yeah. Okay, I'll make changes. Yeah.
We get 1, sir.
1, huh? Final.
Yes.
Okay, this will be mod value how much? Second mod value?
5 by 6, sir.
5 by 6.
5 by 6.
1 meter.
Before it was coming less than displacement, sir. 0.5 means.
Yeah, okay, fine. Huh? So now you see the distance covered. This will be the distance covered. So first it will start moving towards left. Then 1 second it will change direction and start moving towards right. Now average speed, average velocity. I think this will become very easy for after this. What is average speed? Distance called by time taken. Average velocity, displacement by time taken. How the motion? So just I think a student should have. So first it will go like this. Then we'll return back. This will be 2 by 3 meter. So 2 by 3 meter means how much it will be? 0.67. In 1 meter, you remove 2 by 3 meters. So this will be how much? 1 by 3 meter. Sorry, displacement is 2 by 3. No, okay, this is 2 by 3. This will be 1 by 3. Hope like this, a student must develop this particular ability to roughly have a diagram like this. After what time it will be at initial position? Okay, you see that again it will cross that point, no? So how the motion of object will take place? First it will move towards left, then it will return. There's a motion. So the average speed is equal to, and let me finish off, then I'll put it. Average speed equal to distance covered by time taken. 1 by 2, 0.5 meter per second. Okay, this will be 2 by 3 by 2. 1 by 3 meter per second. This will be directed towards right. Plus I cap, I'll write it. Because complete, I'll show it. Little bit that integration is what you have to be alert. So now which one to put mod? I think you need not to bother. Put mod for both. Problem solved. So that's what the skill is, what you have to develop here. in a question, if they ask you, find the how many times the object will change direction of motion. Tell me what you are going to do. This expression for velocity, you're going to put 0, and if you get time, two values, the two values of time positive means, what does it mean? Twice it will change direction of motion. I think so much of things is going to help us a lot. Huh?
Yes, sir.
Sir?
Yeah.
Sir,
Sir, in
velocity is a cubic equation, answer means
solve it, polynomial, you have to solve it.
Sir.
Okay, sir.
Sir.
Sir,
in the above equation, only one side will change the direction, no, sir?
Yeah, because for t greater than 0, it will start the motion. Then it once again change direction of motion.
No,
if you
okay,
get
sir.
t two values, if you get no, twice it will change. T if you get three values, thrice it will change. It
Okay,
all
sir,
depends
okay, sir.
upon the values. How many times the velocity is 0.
Yes, sir. Yes, sir. Understood, sir. Thank you, sir.
Okay, now find the acceleration at time t.
Sir, one question we missed, I think.
I'll come back. Now let me work out some other different types of questions. It's asking us to get find the acceleration as a function of time t. The equation is given of this kind. So you can do one thing. We will start the t equal to x square minus 1, squaring on both sides. If you are not comfortable, at least now you can do it. Okay, that rewriting here. No, let's differentiate with respect to time. So dx is equal to, this will be, it is one more step, I'll write it. 1 plus t squared to the power of 1 by 2. Dx equal to 1 by 2, 1 plus t square 1 by 2 minus 1, derivative of this function. 1 by 2 minus 1 will be minus 1 by 2. So 1 plus t square to the power of minus 1 by, derivative of 1 plus t square will be 2t dt. This bracket one, for your convenient, I'll write it here. So then for finally dx by dt is equal to 2 will get cancelled. This will become t by 1 plus t square to the power of 1 by 2. So again you are going to differentiate. So this is what the velocity expression for velocity is. V equal to 1 plus t square. Okay, now once again differentiating, we'll get the expression for acceleration. Just the same differentiation only was asked for you in different way. So you don't get scared. The equations can be of anything. If you have x as a function of time, then differentiating this equation will get velocity. Velocity again, differentiating as a function of time will get the acceleration. I think that's the core idea. Rest all mathematics. So this will go for dv is equal to 1 plus t square 1 by 2. Derivative of t will be dt minus t as it is. Derivative of 1 plus this will be 1 by 2 1 by 2 minus 1 derivative of 1 plus t square, all divided by square of it. I think this was the quotient rule of the calculus. This will become 1 plus t square dt. This will become t by 2 derivative of 1 plus t square will be 2t dt. So this will end up with only 1 plus t square. This 1 by 2 I and this 2 will cancel out. So this will become 1 plus t square dv by dt is equal to minus t by 2. 2 get cancelled, so t square I think now we have to further simplify this. 1 by 2 minus 1. Okay, this is one quantity, no? Like you can take it, this is x t square.
Sir,
let me
can
see.
we assume 1 plus t square as x and do, sir?
I do whatever you want. Nothing wrong, nothing wrong. Huh? Okay, this will do one thing, 1 plus t square, and here 1 by 2 minus 1. So minus 1 by 2. So this will become 1 plus t square 1 by 2 minus of, and this will be t square 1 by 2 plus 1. This will become 1 plus t square to the power of 3 by 2. I think we can, okay, so this will be very lengthy. We can do it here in this way.
T square will cancel.
Yeah, this t
Numerator
square
will
in the
be
numerator
cancelled.
t square again 1 plus t square 1 by 2 1 by 2 will become 1. So this will become 1 plus t square. I'll do one thing. This will be a better idea. 1 minus t square by, this will be 1 plus t square. Okay, finally this will become 1 plus t square 1 by 2 plus 1 by 2 will be 1. T square, so this will be 3 by 2. Okay, now this will become only 1. There come for what is 1 plus t square is x square, no? So this everything will become 1 by x cube. Some math based purely the okay, you can see this. You can use any method. You can use any method. Okay, what is further? Okay, I'll write this acceleration as dv by dt, no? This will be our answer final. So you can expect some questions of like this. I think you have to be very sure about the differentiation. I'll scroll down. We'll take the next problem.
Just a second.
Okay, now let me take the, one more.
Sir, there in the previous question, sir, acceleration is, we have to find the acceleration at time t, no, sir?
Find the acceleration as a function of time t. Okay, that one. I brought both the things. This will be your, as a function of position. The last answer here, last but one will be function of time. Okay. You end up here only. Function of position means you have to write in this.
Okay, sir.
Hmm? Okay, take this one. Find the retardation of particle. Himself is asking, find the retardation. Again, solving for x, better directly differentiate this. No, it's a big headache. Again, simplifying for x, it's a quadratic equation will come all that one. So directly we'll differentiate this equation. So this will be t equal to ax square. Okay, that's alpha. It is a alpha x square beta x. Dt is equal to alpha 2x dx beta dx. Dt equal to dx 2 alpha x plus beta. Dx by dt is equal to 1 by keep it in this way. This will difference. This is what the velocity. But what is the problem is like is asking acceleration. What we have is velocity as a function of time. Shall we differentiate this with respect to time? Yes, you can differentiate. So with respect to time, you can differentiate. So dv by dt, this will become the whole quantity is equal to like beta plus 2 alpha x minus 1. So the function will be minus 1 into beta plus 2 alpha x minus 1 into derivative of this one. No, dv. Okay, next step I'll bring it. So this will be minus 1 as it is. So this will become beta plus 2 alpha x whole square. Derivative of this will become 2 alpha dx. So what you did, I just differentiated v and x. So then dv by dx is equal to minus 2 alpha. But we wanted acceleration, no? What to do? We have one more formula, acceleration equal to v dv by dx. What is v is equal to 1 by beta plus 2 alpha x. dv by dx is minus 2 alpha now what is beta plus 2x is equal to v, no? So finally beta plus 2x is what v? 1 by beta. So this will become minus 2 alpha b cube. Actually, we should not write. If we ask acceleration is a function of speed, write like this. This should be our answer. If you want, you can bring in terms of speed also. So just I think more about the differentiation integration. Those things, if you are familiar, later on the definitions, acceleration, dv by dt, acceleration v dv by dx, with that we can manage most of the things. I'll go for the next problem.
Sir, on one.
Okay, this one, yeah. Later, once again, we are going to discuss graphically all these things. So the next week, kinematics graphs will come. No, all this will come into picture. There will focus more on the graphical interpretation, plotting graph, everything. Now we are more bothered about only the the calculus part. If you know one quantity, how to get the other quantities using the integration or differentiation. This will be our answer. Okay, I think some question we have here. We'll go for it. A particle moves along x-axis in acceleration equal to kv square with initial velocity u. Find the velocity of particle as a function of displacement. Velocity of particle as a function of displacement is asking. So this acceleration, I'll write it as v dv by dx. So one v will get cancelled. So dv equal to v by k dx. One v on the either side will cancel out. So we'll end up with this one. So the limit will be, so the limits at as a function of displacement. We'll assume it initially, its initial velocity as a function of x, let it be v. So this will become log v kx will come. So then next further log v minus log u. So this should become equal to kx log of v by u equal to kx. Then v by u equal to e to power of kx. So v equal to u e to power of kx. So what was the question asked? Find the velocity of a particle as a function of displacement. Okay, this is what we have brought it. Now, instead of this, like a as a function of time, can we do it? Now, instead of writing this, we can also begin in other way. Let's see what will end up. Limit at t equals 0, the initial velocity is u. At any time t, let be v. So then this will become v to power of minus 2 plus 1 minus 2 plus 1 kt limit u v equal to kt. So this will be v minus 1 minus 1. The negative sign. Okay, this will become minus 1 by v minus 1 by u minus kt. So further simplification of this will be 1 by u minus kt. V equal to u by 1 minus u kt. If you ask find the velocity of a particle as a function of displacement, this will be your answer. Velocity of particle as a function of time, this will be your answer. A student must have all the things like acceleration. If it is given as a function of speed, it's left to you. So like in a question, so what happened, they can ask you either way. No, acceleration you can write it as v dv by dx or acceleration as dv by dt. Please try to follow this. I'm trying to highlight. Depending upon the situation. And now I'll ask you the position. From here, I want position, what to do. Position as a function of time, what to do. V as ds by dt, then we are dx by dt, then we are going to integrate. Are you able to understand now? So this will be, or else you can come for this one. V, what you can write, dx by dt. Then we are going to integrate. You solve either this or this, we'll get the same answer. So from acceleration, it can be acceleration as a function of time, position, speed. I can ask you any of the quantities. The integration differentiation matters a lot. Make observation, we'll take the further few more problems. There's no limit here. We can ask you any of the numerical here. No, there's nothing called like a practicing numericals like that. You better understand methodology. No need to solve several numericals. But I think at least some 10, 15, 20, when you do it, no, you get to that idea. Oh, this is what I should do. Okay, I think I'll give one more, some mass based. I'm going to test your mathematical skills. A particle starts from rest and moves with an acceleration equal to 4 minus mod of t minus 3 meter per second square, where t is in seconds. Find the velocity of particle at t equal to 4 seconds. See, mass is not about just like mere. What is the meaning of that equation? What does it mean? This part you try to focus rather than just blindly doing question answer. What is the purpose of that? Why you are learning? When you leave all that one, no, the trouble will start of this kind. So that mod is something very important. Now interpret that mod, what role it is playing here. We'll break up this acceleration. The equation will end up like this: 4 minus t minus 3. This will be the equation for t less than or equal to 3 seconds. I have to check the answer. I don't have answer. I have to verify. This will become 4 plus t minus 3, the equation for t greater than 3 seconds. This is the meaning of that.
Sir, it should only be less than 3 seconds.
I'm not understanding.
So for first one, it should be only less than 3 seconds, sir, not equal to.
Okay. This one, yeah, fine. Yeah, we'll make it like this, huh? So why you are doing like this? Put t equal to 1. Put t equal to, will it satisfy that equation? Put t equal to 1. 1 minus 3 minus 2. Mod of minus 2 will be 2. 4 minus 2 will be 2. Put t equal to 1 here. 1 minus 3. will be -2. So I think some problem is there, no? Like, sir, how you are, why, first of all, why you are writing this? T can be for t less than 3, for t greater than 3. The interpretation of the equation is something very important because of that mod. For t less than 3 seconds, for t greater than 3 seconds. But what was the question asked? The question was asked to get only the, find the velocity of particle at t equal to 4 seconds. Well,
Sir?
Yeah.
Sir, for t less than 3 seconds, 4 plus t minus 3 you'll get, no, sir?
That's what
reverse, sir.
Yeah, I just wanted everyone to analyze once.
Okay, sir.
For t less than 3, look at the equation t equal to 1, 2, 3, put it. Will it satisfy equation 1 or 2? Then put t greater than, put t equal to like a 4, 5, 6, like that. Then which equation satisfy? I think this will be no, why don't you look at the mathematics involved here rather than just simply addition, subtraction, Abhiram? Okay, will it satisfy this equation? Everyone verify it with mathematics. Put t equal to 1, put t equal to 1, 1 minus 3 minus 2. So mod of that will be 2, 4 minus 2. Okay, fine. T equal to 1, you put it. 1 minus 3 minus 2. 4 minus 2 will be 2. Yes, in fact, the equations are in fact satisfying here. Now, okay, it's asking find the velocity. So what is acceleration? We know acceleration equal to dv by dt. This further dv is equal to a dt. Now the limits are going to help us a lot. 4 seconds is asking. So 0 to 3 will put and 3 to 4. Because altogether now the velocity is asking. So dv equal to 0 to v. This will be a dt plus a dt. 0 to 3, 3 to 4. Now why we should do like this all? So will you take mod here? Why you are not taking mod? Previously you took mod. So look at this equation. It will be this will be 1 plus t will come. This equation will be, and the other equation will be 7 minus 3. The acceleration of particle is defined by this equation. This equation interpretation is what we are, that mod is what we have to define it properly. So let me break up here. This will become a equal to 7 minus t. This is, and this will become one plus t. The acceleration of particle itself, what happened, will not be this one. For 0 to 3 seconds, it will be 1 plus t. For t greater than 3 seconds, the acceleration of particle will be 7 minus t. So therefore, I'm going to break up the limit here. Now, what should be the value for this one? 0 to 3 seconds. So what is the value? 1 plus t. This equation you have to substitute. And for 3 to 4 seconds, the equation is 7 minus t. This limit integral dv will be v. Now you substitute limit, you are going to get the velocity as a function at t equal to 4 seconds. Don't put mod here. We're asking velocity at that instant. So this will become integral of 0 to 3 dt . T. So this will become t square by 2, 0 to 3, 7 limit I'll write one step. 3 to 4 t square by 2 3 to 4 t cube plus this will be 3 square 1 by 2 4 minus 3 minus of 1 by 2 4 square minus 3 square 399 by 2 7 16 minus 9 will be 7 minus 7 by 2. Okay, I'll change it. It should be only 3 minus 0. $11, huh? Okay, yeah. Okay, the equation, the mod meaning here it is like this. The acceleration of particle for less than 3 seconds, for more than 3 seconds is different. That's what he just is going to put by mod.
Sir, at t equal to 3 seconds, the acceleration of the particle will be what, sir?
Let it be.
Which equation we should use?
Why?
First one or
No,
second one?
I don't know, some minimum common sense, like minimum common sense is asking at 4 seconds. No, at t equal to 3 seconds, the mod is there. No, so therefore you have to break up this 0 to 3 and 3 to 4. That's why the limits are there here, t greater than 3 and t less than 4. I will go for the last one more problem. We took only acceleration. No, now I'll bring another condition. The acceleration of a body varies with the acceleration of body is given by A equal to minus 10v at t equals 0. The speed of the particle at the speed of the body is the speed of the body was, it is 10 meter per second. The maximum distance traveled by the bodies. Find the maximum distance traveled by the body. Look at that negative sign. What do you mean by that? It's like a retardation, no? But still I'm writing acceleration. A equal to minus 10v. So that minus 10v what is the question? Find the maximum distance traveled. Okay, we'll see what is that maximum distance traveled. First of all, to get the distance traveled, we need speed. So I'll start this one. So this dv by dt will write it. Any help will get it. S dv by v is equal to minus 10 dt. This will the limits will go for it. So what are the limits given? At t equals 0, the speed of the object is 10. At any time t, let it be v. Then this will become log v, 10v equal to minus 10t. Substituting upper and lower limit, log v minus log 10 is equal to minus 10t. Log of v by 10 equal to minus 10t. Log I'll send other side. V by 10 is equal to e to power of minus 10t. So where v is equal to 10 e to power of minus 10t is asking distance covered. Further, I'll write it as v as ds by dt. ds equal to 10 e to power of minus 10t dt. This will integrate further. ds equal to 10 e to power of minus 10t dt. Now limit 0 to t, 0 to s. We'll assume that initially it is at our origin. So not given at t equals 0, the speed of the body was 10 meter and is at origin. If it is not at origin, I would have mentioned. I think there's one, most of the problems in the books, they have this convention. If it is not at origin, I'll mention. If it is not given means you can assume it to be at origin. Okay. Now this will be further s is equal to 0 to s 10. Now what is the integral of e to power of the limit it should be e to power of, so minus 10 is there. So this I'll multiply with the everyone. I will write it first somewhere here. I'll bring that integral formula. E to power of x dx will be e to power of x only. E to power of alpha x will be 1 by alpha e to power of alpha x. E to power of minus alpha x should be minus 1 by alpha e to power of minus 1 by alpha x. Why it is? The area under the curve is what? The area under the curve is what? The integration of the meaning of that. Dx is missing. I'll add up dx. Now you see this. So what shall I do now? Just multiply 0 to s. So 10 is there. So this will be minus 1 by 10 e to power of minus 10t. Limit will be 0 to t. S is equal to, this will be minus of, we'll substitute limit. This will be e to power of minus 10t minus of e to multiply with anything will be e to power of 0 only. So this will become 1 minus e to power of minus 10t. What we got? Maximum distance traveled by the body. What to do here? You know this function. I hope I plotted graph also. Unless if you have not interpreted the graph, very difficult to conclude anything. I'll bring the graph into the picture. Already we have studied exponentially increasing one. This is it. The curve is this will be 1. This is S. This is T. When it will be at maximum distance at t equal to infinity. At t equal to infinity, check it. S equal to 1 minus e to power of anything infinity minus infinity. Okay, they become cross. I'll write in clearly. Minus 10 infinity. So this will become anything to the multiply with infinity will be infinity. E to power of infinity will be infinity. 1 by infinity is 0. Finally, I'll get this is the maximum value, no? What is this, sir? It will travel only 1 meter. It's an object which is described will be of this motion. You should be very strong in your mathematical abilities. Very, very, very strong.
Sir.
Yeah.
Sir, you got in the last second step, sir, before getting s is equal to 1 minus e raised to power minus 10t.
Okay.
There I'm unable to understand it, sir. Like what you did.
Upper limit and lower limit. In the upper limit, put t. In the lower limit, 10 into 0 will be 0, e to the power of 0, 1.
Okay, sir. Understood, sir. Understood.
Very arbitrary way of questions will come. Just don't get scared. Acceleration, you want the like a distance. So what you should do, first you get velocity, a equal to dv by dt. Then from velocity, again you get the ds by dt, you write it, you'll get the distance. If you know position, how to get the velocity, first differentiate. Then you differentiate velocity, you'll get acceleration. I think it's a reverse, no? If you know acceleration, how to get the distance, integrate twice. If you know position, or if you know the distance or position displacement, how to get the acceleration, differentiate twice. I think this is a background. Acceleration function of time, better to write a as dv by dt. Acceleration function of position or the distance or displacement. In that case, what we write, v dv by ds. So these are the things a student should compare problem to problem. Oh, in this problem, this is like this. If the question comes like this, we should think in this way. He has to sort out things on his own. Then you'll be on safer side. I think I took a lot of time. So, okay, practice some questions. I'll calculus based are there. Today I'll send the from that icon and one this Cengage book. No, what all the questions are there? I'll just give the number. You can practice them. It's a just math build. The meaning of this we are going to learn in graphs, like the equation I plotted here. You can see the last one curve I plotted. This is actually the how, sir, will it move upward like this? No, the object is moving. Its position versus time graph is what I've shown. What is this? There's a position. Don't think that object will move, will jump like this. No, the object will just move. Its position, when it will attain, when it will at a maximum distance at t equal to infinity, to be the distance of 1 meter from origin. The interpretation of graphs is something very important that we'll see later on. There again, once again, all this maths will come. At that time, you feel a little bit easier. Just practice few more questions on your own. So you'll get a confidence that is enough for exam. Okay. Okay, kids, I think a lot of some mass drilling happened. I think some of you are really got scared. Okay, nothing, at least what all I taught. Okay, try to understand and practice few numericals so that you'll gain a confidence. Okay, and it's something again next week, the graphical questions will come there. Once again, all this type of maths will come. Little bit you feel comfortable next time when we go for graphs. Okay, thank you all of you. Take care, bye, see you. We'll end up the class.
Thank you, sir.
Thank you, sir.